Okay, so here are some of the questions that we did in our class. So a telephone number contains 6 digits. How many possible telephone number are there in which no digit is repeated? Okay, so let us check how many digits do we have in total. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then since we need to have 6 digits, we are supposed to have 10 be 6. So out of 10, you simply need to arrange 6 of them. So it should be 151, 200. Okay, so how many ways can you arrange the letters from the word codes? So now we want to arrange codes. So let us check how many N is this. 1, 2, 3, 4, 5. So the number of letters is 5. And then we want to arrange everything actually. So we are supposed to have 5 factorial. So nothing with identical. So simply 5 factorial. So this is simply 120. Okay, so at Scrabble you have the letters Z, X, Z, J, Y, B, V, K. How many 3-letter arrangement can be made from them? Okay, so let us check how many letter is this. So 1, 2, 3, 4, 5, 6, 7. So the total number of letters is 7. However, we need to make 3-letter arrangement. Therefore, it should be 7B3, which is simply 210. So the fourth one, how many numbers between 100 and 1000 use only odd digit and no digit will be repeated? So 100 and 1000, so that means we must prepare 3-digit number and then we must use only odd digit. So let us see what is the odd digit. The odd digit can be 1, 3, 5, 7, and 9. So that means in total we have 1, 2, 3, 4, 5. So 5 digits. But since we need to have 3 digits over here, we are supposed to have 5B3, which is simply equal to 60. Okay, so in case you were wondering, how do I know that this is 3 digits? So between 100 and 1000, so our value might be 101 until 999. As you can see, those are 3-digit number. So that is how I know that I must have a 3-digit. Okay, so question number 5. How many arrangements are there of the letters from Brain in which the vowel are together? So the vowel here, so we have Brains, so that means A and I are the vowel. So we have A and I as the vowel, so those must be together, A and I. And then we have individual, B, R, and S. So that means in total, I have to arrange one group and 4 individuals. So 1, 2, 3, 4, 5. So altogether, we have 5 things to arrange. One group, 4 individual. However, in this group, I need to consider another 2 arrangement for them. So 5 factorial, 1, 2, 3, 4, 5. 2 factorial is simply focusing on the group. So 5 factorial multiplied with 2 factorial. So this is 240. Okay, so how many arrangement in which the consonant are separated? So the consonant are D and H. So D and H, we will separate them, D, H. And then we simply need to write the vowel. So the vowel is I, A, and O. So 1, 2, 3. Okay, so firstly, arrange the consonant first. Arrange the consonant 2 factorial. For the arrangement of the consonant, multiply with 3 factorial, the arrangement for the vowel, and this simply equal to 12. In how many ways can 7 men, 8 women, if no 2 women can sit next to each other? So we must separate the women. So the women are 8. So 1,
2, 3, 4, 5, 6, 7, 8.
And then since I need to make sure that no two women can sit next to each other, and I have to write the men. So the men can be here.
Here, 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 or here.
So 1, 2, 3, 4, 5, 6, 7. Okay, so firstly, arrange the woman first. So it will be 8 factorial. And then arrange the men, which is 7 factorial. Therefore, the answer for this one will be 2, 0, 3, 2, 1, 2, 8, 0, 0. Okay, so let us proceed with the next question. So we have 5 Western books for romance. In how many ways can they be arranged without any restriction? So since we don't see that these are identical books, they are different books. So that means in total we have 9 books to arrange, therefore 9 factorial. So this is 3, 6, 2, 8, 8, 0. Okay, so again, similar question, except that now all the Western are together and all the Romance are together. So all the Western together. So these are the group for the Western. So I have 5 Western, and then I have another one group for the Romance. So 4 Romance. Okay, so that means I have one group, 2 groups. So 2 groups to arrange. So 2 factorial. Multiply with, so let's go to each group. So we have 5 books over here. So 5 factorial. Multiply with 4 factorial. So this is equal to 5760. Okay, so let us proceed with the next one. So same question again, but now we want all the Western to be together. So all the Western need to be together. So do one group for them. And then we have the Romance, Art 1, Art 2, Art 3, and Art 4. So all together we have one group to arrange. 2, 3, 4, 5, 5 things to arrange. So 5 factorial. Multiply with, if we look at this group, we have 5 Western. So 5 factorial multiply with 5 factorial, which is simply 14400. So in how many ways can they be arranged if no two Western are together? Okay, so no two Western are together. Let us separate the Western. So Western, 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 Western. So I cannot have them together. So that means I need to have the Romance book somewhere in between. So 1, 2, 3, 4. Okay, so to arrange the Western first, so 5 factorial. Multiply with arranging the Romance book, so 4 factorial. So 5 factorial multiply with 4 factorial. So this is simply 2880. So a few more. Okay, so 3 married couple are to be seated in a row having 6 seats in a cinema hall. So in how many ways can they be seated? So each couple need to be seated next to each other. So let us draw the couple. So we have couple 1, couple 2, couple 3. Okay, so that means I have 3 groups to arrange. So 3 factorial. For each group, I will have husband and wife. So that means 2 factorial for the arrangement of husband and wife. And this one is husband and wife as well. So another 2 factorial. This one also husband and wife. So multiply with another 2 factorial. So this is simply equal to 48. Okay, so now find the number of ways of their sitting if all the ladies sit together. So the wife gonna sit together, wife 1, wife 2, and wife 3. So since they are sitting together, let us do one group for them. And then we have husband 1, husband 2, husband 3. So no specific seat for this. Okay, so we have one group and 3 individual. So altogether, we have 4 things to arrange. And then look at the group, you have 3 individual. So multiply with 3 factorial. So 4 factorial times with 3 factorial, this is 144. Okay, so using the digit 1, 2, 3, 4, 5, 6, 7, a number of 4 different digits is formed. How many number are formed? Okay, so we need to have 4 different digits. So that means you need to have 4 spaces. And then since we need to use different digits, so 1, 2, 3, 4, 5, 6, 7. Out of 7, simply arrange 4. So 7p4, which is 840. Okay, so using the digit 1, 2, 3, 4, 5, 6, 7, a number of 4 different digits is formed. So again, we have 1, 2, 3, 4. Find how many numbers are exactly divisible by 2. So what we mean by exactly divisible by 2 is that if we divide by 2, the balance should be equal to 0. In another way, it simply means that we want to find an even number. Because every even number, if you divide your even numbers by 2, your remainder is definitely equal to 0. So that is how we know this is definitely need to be even number. So even number, I need to restrict the last digit. So the last digit can either be 2, 4 or 6. So that means I have 3 choices for the last one. So since we need to use different digits, so 1, 2, 3, 4, 5, 6, 7. So I started with 7, but one of them has already become the last digit. So that means I will be left with 6, 5, and 4. Therefore, it should be 6 times 5 times 4 times 3, which is simply equal to 360. Okay, so now the last question. Using the digit 1, 2, 3, 4, 5, 6, 7, a number of 4 different digits is formed. So again, 1, 2, 3, and 4. Find how many numbers are exactly divisible by 25. In order to make sure that the number are exactly divisible by 25, I have to make sure that the number should either end up with 25, 50, 75, or 0, 0. However, I don't have anything with 0 here. So deleting 50 and 00. So I should either end them up with 25 or 75. So that means the last digit, I have no choice but to end them with 5. So only one choice over here. And then this one should either be 2 or 7. So that means I have 2 choices for here. So I start with 1, 2, 3, 4, 5, 6, 7 digit, but one of them has already become the last one. So delete 5. Now I'm left with 6, but either 2 or 7 will become the second digit. So deleting either 2 or 7 now. So I'm left with 1, 2, 3, 4, 5, the 5 digit here. So this is 4 digit. So it should become 5 times 4 times 2 times 1, which is simply equal to 40.